All right, so far we've talked about circles with center radius form. We talked about general form. We talked about going between general form to center radius form and then from center radius to general. We did that yesterday. And we've talked about the distance formula. So we're going to use some of those ideas again today. We're going to expand a little more, try to do different types of problems than we have done. So we're still going to deal with the equations of the circle. So as you see, we're going to have center radius form. Down here, we're still going to have our general form. But we're going to add a little twist to it and try to solve for something that we haven't solved for yet. Okay? So let's just go ahead and get started, and you'll kind of see how it works. So consider the equation of the circle. So that's given in center radius form, whose graph is pictured below. So before we even start, let's make sure that we remember how this works. So the center of our circle should be where on the graph if you look at the equation? Should be where? Should be at 3, -4, and it is. So that's good. What about the radius? What about the radius? Addison? Addison? 4. Yeah, you take the square root of 16. 1, 2, 3, and 4. Next time just have a pass, please. Okay? Thank you. Alright, so it is 4. Square root of 16 is 4. So that is the equation of that circle. So part A. Let x equal to 0 and solve for y. Do your results make sense in terms of the graph y or y not? So we're going to take the equation of the circle and put 0 in for x. If we reduce this, we get 9 squared here. Let's leave this as y plus 4 squared for right now, equals 16. Let's subtract the, oh, sorry, that's not 9 squared, that's just 9. 3 squared, sorry about that. -3 times -3, that is 9, not 9 squared. Okay, and I want to subtract the 9 over, so I have y plus 4 squared equals 16 minus 9 is 7. What can I do to both sides now? Square root, yeah. Take the square root of both sides. You get y plus 4 equals plus or minus square root of 7. So let's get y by itself. So y is equal to -4 plus or minus square root of 7. Go ahead, get a calculator, give me the 2 decimal answers for that. 2 decimal answers. Alright, who has one or both of them? Somebody give me one. Yeah, go ahead. -1.35. I have -1.354, but yeah, if you round to 2 decimal places, that's fine. Anybody have the other one? The other one is what? Kyle? Yes. -6.646. Okay, so we have 2 answers for y, so let's think about what we actually found here. Think about the value that you plugged in for x. Think about the values that you got as answers for y. Look at your picture and try to think if this answer makes sense. So it says, does your result make sense in terms of the graph? So look at your graph and decide whether your answer actually makes sense. What did we find?
It is when like the graph goes over the y.
Yeah, it's where the graph of the circle touch the y-axis. We found both of those points. At 0, x equals 0, we found both y values. So does it make sense? Yes. Because these values are y-intercepts. They're y-intercepts. Alright, part B is very similar, but on part B we're going to let y equal to 0 and solve for x this time. So take the original, x minus 3 squared plus 0 plus 4 squared equals 16. X minus 3 squared plus 16 equals 16. 0 plus 4 is 4. 4 squared is 16. X minus 3 squared, get it by itself. For this problem, do we actually need to multiply the x minus 3 squared out? Or take the square root of both sides? Do we need to do that for this problem? What'd you say, Mario? No? Why not? Do we know what our x value is? What would it be? 3. It's equal to 0. Since we have the factors equal to 0, we can just say that x is equal to 3. Again, like we did in part A, think about your answer. Think about what we plugged in for y. Think about what your result was for x. Does it make sense, and what actually is that value? So, first question, does it make sense? Yes, it makes sense. What is that value, though? We found the value of the x-intercept. Yes, because this value is the x-intercept. Very good. We're good with A and B then? Alright, part C. Graph the line defined by the equation x minus y equals 3. At what point or points does the graph of the line intersect the graph of the circle? Verify your results algebraically. So in part C, the steps we're going to go through, these are really the same steps we're going to go through for the rest of the problems we go over today. So pay attention to the actual methods that we use to solve this problem. As we go on, the answers are going to look different, but we're going to use the same method each time. Okay? So they want us to graph the line given by this equation. So what we need to do first is put that equation into y equals mx plus b form. Makes it easier to graph. So now we're going to go back up after we find that and graph it. So we have minus 3. Our slope is 1. So we're graphing this line on the same graph as our circle. So the ultimate question is, where do they intersect? Yes, we can look at the graph, but they want us to verify it algebraically. So if we look up here, what are the coordinates of the intersection points? Where does the line intersect the circle? What are the two coordinates? Really close on the second one. Yeah, -1, -4. So those are the 2 points that we hopefully can get algebraically to prove that that's correct. So those are the points we want to try to get. Alright, so it said graph the line. Well, we already did that. At what points do the graph and the line intersect on the graph of the circle? So what we need to actually do is, if we look at the original, so let's write the original line of the circle down, or the equation of the circle, sorry. X minus 3 squared plus y plus 4 squared equals 16. If we have 2 unknowns, are we able to solve for one of them and actually find what the value is? No. If we have 2 unknowns, we could solve for that unknown in terms of the other one, but we wouldn't actually know what the value is. So we need to replace one of these so we can write them in terms of the other. How can this help us? What could we do with this x minus 3? Kyle? Yeah, we already have it solved for y, so we can take that all the way up here and substitute that in for y. That way we only have x's in our problem. So we would have x minus 3 squared plus, in for y we would have x minus 3, and then we still have a plus 4. I'm going to simplify it here. What's x minus 3 plus 4? What's your simplified version? X plus 1 squared equals 16. Now, once you get this form, what you have to do is you have to square both of them, so get all of your terms, and then combine like terms. So x minus 3 squared becomes x squared minus 6x plus 9. Then the x plus 1 squared becomes x squared plus 2x plus 1. Are we okay up to this point? Just expanding. Now we can combine like terms. So x squared and x squared, we get 2x squared minus 6x plus 2x minus 4x. Positive 9 plus 1 is 10, but we want to get it equal to 0, so if we subtract 16, 10 minus 16, we get negative 6 over here, equal to 0. So we have a quadratic now. And what are the 2 ways that we've been solving quadratics? 2 methods. We like one better than the other. Addison? Factoring and quadratic formula. Well, let's hope this can factor. What can we do first to maybe make it a little easier to possibly factor? Simplify how? Yeah, divide everything by 2. X squared minus 2x minus 3 equals 0. Now let's try to factor. Alright, any luck? Any luck factoring? Brooke? X plus what, sorry? Yep. X plus 1, x minus 3. So our x values are x equals negative 1 and x equals positive 3. So what do you think I need to do next? We graphed the line, it told us to graph it, so we did that. And it is asking us to find the pointer points where the graph intersects. But we just found 2 x values. Mario? Yeah, we can plug it back into our y equation and get our 2 y values. So we would have y equals, well, let's choose the first x, negative 1 minus 3. The second one would be 3 minus 3. And what are your 2 y values? Well, negative 1 minus 3 is negative 4. 3 minus 3 is 0. If you write those as points, well, we plugged in negative 1. So this is negative 1 comma negative 4. This one is 3, 0. Is that what Rebecca told us at the beginning? Yeah, those are the two values we actually wanted to try to get. Those are the 2 points where the line we drew intersects our circle. So again, we're going to use the same process. You take the line, you need to graph it, so solve it for y. You plug it into your circle equation, expand it, try to factor if you can. If you can't factor, then you have to use quadratic formula. Okay? Are we alright with those steps? So let's try the next one. Again, same process, but we're going to get answers that are a little different. The graph of the circle is defined by the equation, and this is in general form, pictured on the right. On the grid, graph the line defined by the equation 2x plus 3y equals -6. Algebraically find the points where the line intersects the circle. So we have 2x plus 3y equals -6. Solve that for y. You get -2/3 x minus 2, and you need to graph that. So when we solve, just by looking at the picture, should we still get 2 answers? Okay. So we already solved for y. We know that we're going to have to plug this in, but we need to plug it into the original. So let's go back up to the original. I think with this marker I'm probably going to run out of room writing it, but we have, let's start with x squared plus, and instead of y squared I have to plug in -2/3 x minus 2 squared, plugging that in for the y, plus 2x plus 6, well I need y again, so that's -2/3 x minus 2 plus 1 equals 0. We actually had 2 y values this time, so you had to plug it into both. Good so far? Alright, so now we're going to expand, but with this one it's going to get a little messy. We're going to get a few fractions, but I'm going to show you a trick if you have a problem like this to get rid of your fractions, so you just have to deal with whole numbers. So first off we're going to expand a little bit. So we get x squared, and you would get plus 4/9 x squared plus 8/3 x plus 4. Then plus 2x minus 4x minus 12 plus 1 equals 0. Still alright with expanding that? So now we have the fractions. We have the denominator of 9 and denominator of 3. So what we can actually do to make these all whole numbers so we don't have to worry about finding common denominators is if we multiply everything by 9. Multiply every term by 9, it will cancel the denominators and make them all whole numbers. So if we multiply everything by 9, we get 9x squared plus 4x squared plus, what about the 8/3 x? If you multiply that by 9, what do you get? 8/3 and multiply that by 9. Or sorry, yeah, the 8/3 multiplied by 9. You get what? As you Yep, 24x exactly. Okay, then we get plus 36. Then we get plus 18x, yep. We get minus 36x. Minus 108. Plus 9 equals 0. Anybody stuck on how we got here? Alright, so now we have a lot of terms. We don't have any fractions to worry about, so let's combine all of our like terms, make it a little easier to look at. 9x squared plus 4x squared, you get 13x squared. If you combine your x's, 24x minus 36x, and you have 18x in there, so you get plus 6x. And if you simplify your negative 108 with the plus 9 and the plus 36, you get negative 63. Does this look like it's going to factor? Probably not. So let's go ahead and get the quadratic formula. The opposite of b, plus or minus square root of b squared, which is 36, minus 4ac all over 2a. So that is the quadratic formula filled out. Take a moment with your calculators. I need 2 decimal answers. Any luck? Anybody have any of the decimal answers? Okay, Kyle? Good, that's one of them. Anybody have the other one? Remember, you have the plus or minus, so that's why you get 2. You have the plus or minus. So you should get 2 different values. Mario? That's not what I got. Simplify the inside of the radical. Did anybody get a value for underneath the square, or actually what you got the square root of? What is this value? I did not get 343. Did anybody else get a different value for the square root here? Yes? 3312. Let's try it. I did not get that. So we have 36 there. We already did 6 squared. Were you guys squaring the 36? The 36 was already 6 squared, so we don't have to square 36. Leave the 36 there. 4 times 13 times negative 63. You get negative, let's see. And then you have to do 36 minus that, so you get a positive. After I took the square root, I got 57.5. Anybody get 57.5 just as the... You got that over there, Grant? You got it now? Okay. Now find your two answers. You take the negative 6 plus that number and divide by 26. Then you take the negative 6 minus that number and divide by 26. You'll get both of your values. So we already have the 1.983. We need the other value. Negative 2.444. Exactly. Again, we have both of our x values. That's what we found. Two x values. But we need to go back here, plug them in, and find our y values so we have 2 points. So go back to this equation here, the negative 2/3 x minus 2. Plug in your x values, and let me know what your two y values are. You should get 2 decimals again with your y values. Plug these both back into this equation. This is the last step to find your 2 points. Alright. Jack, were you able to get one of them? At least one of them?
Negative 0.371.
Negative 0.371. Very good. Do you have the second one too?
Negative 3.322.
Negative 3.322. Thank you. So after you plug both your x values back in, you should get these as your two y values. Negative 0.371 and negative 3.322. Again, then you could list your 2 points. So this point up here where it crosses, that would be negative 2.444, comma, negative 0.371. That's for that first point right there. And this point would be 1.983, comma, negative 3.322. So we found the 2 points. Before we move on to a similar problem but different result, do we understand this result? Okay, let's go ahead to the back then. So on the back, again, it follows the same steps we've done for the last two. So I'd like you to start this one on your own. I'll help you along with it. I'll put some answers as you check yours up on the board so you can follow along. But I'd like you to start. It's going to be the same steps, like I said. Your result will be different though, so don't expect to get the same type of answer like we did on the other two, but go through the same steps. So go ahead and start. First you need to graph your line, so you'll have to find that, and then use the circle equation. So go ahead and start. If you finish the first step, you could check your answer up on the board. Remember, after you solve for y, you then have to plug that back into your circle equation. Again, in this problem you get a fraction. How can you get rid of the fraction so we have all whole numbers? Multiply by 4, yes. So I have mine expanded and then I combined like terms, if you want to check up to the point where I combined like terms. At this point, you have to solve the quadratic. Does it look like that can be factored? Probably not. So go ahead and get the quadratic formula and solve it. When you get this one, don't solve the quadratic all the way to a decimal. When you start solving, you'll understand what I mean by that. But start the quadratic and you'll understand why I don't want a decimal. So I have part of the quadratic formula up here. What I want you to do is tell me what you get when you simplify underneath the square root. Mario? I did get a negative, but it wasn't quite that. Kyle? Negative 464. You okay, Brooke? Which part are you trying to look at?
Where'd you get the negative?
Okay, so inside the radical for quadratic formula, you have b squared
Oh, it's
minus 4ac, and that's where you get that value from. Are you okay with that now? It's not plus? Okay. Before you simplified, so it would be b squared, so 16 squared, minus 4 times 5 times 36. Because it's b squared minus 4ac times 36.
With the negative being inside of parentheses for 16 squared.
Yes.
I'm just wondering if that could be.
Yes. Any value there, because the value they're asking about is b. Well, b is negative 16, so negative 16 squared becomes a positive value. Yes. Mario, are we good? Okay. Brooke, we're good? All right. So this is the value. Now think about this answer. Think about this answer. Think about your picture. What did we actually find? What's being told here? Okay. Addison is right. We have two imaginary answers. Does that make sense with your picture? Yeah, it never touches your circle, so we can't have any real answers. There's no point in time that this line will ever touch that circle. So the only answers we get are imaginary because it never touches. Very good. Any other clarifications, or we're okay for the next one?
So do we have to find?
So at this point, does it ever touch the circle? No, and they're asking for the points of the circle. So we found that the two x's are imaginary. Do we need to find the y's? No, because there is no point that it actually touches the circle. Okay? All right, let's go to the next one. Again, number 4. It's the same process. Go through the same steps. You're going to be able to get rid of fractions just like we did before. But again, the answer is going to be a little bit different than the other ones we've done. So go ahead and follow the same steps as before. You have to find your y, graph, and then use the circle equation. So go ahead and start that one. You done, Gary? What did you multiply by to simplify the fractions in this one? 4. Yep. Multiply by 4 again. What can I do before I try to factor or before I do the quadratic formula? Simplify, I can do what, Addison? Pull out a 5. Now it'll be easier to determine whether it factors or if I have to use the quadratic formula. Anybody have any luck out there factoring? Addison? X minus 2 squared. Very good. Once you have a factor squared equal to 0, you don't have to actually solve it. You can just say that your x value is equal to 2. Very good. And again, you have an x value, so now you need to take that x value back to your y. So go ahead and solve for your y value. Anybody have the y value after you plugged your x back in? Rebecca? Yep. You get 4, very good. Think about your answer, look at your graph. Does this solution make sense? Yes, it does. So before we are done here, we need to say one thing. So yes, it does make sense, But this line touches how many times? Once. Since it only touches once on this line is said to be tangent to the circle because it only touches at one point. So you need to make sure you say that. This line is tangent because it only touches once. Are we okay with that answer? All right, go back to the previous one real quick before we pack up. So we did say that it was imaginary answers, and we said that it didn't touch, so it made sense. So just make a statement here so you know when you're referring back that there are no points of intersection because your solutions are what? Imaginary. Exactly. So there are no points of intersection because your solutions are imaginary. Alright, we have a few minutes left but not enough time to continue on. So tomorrow we're going to continue with the graphs of semicircles. So we will finish up circles and then we'll probably start ellipses. Alright? Have a good day.